Good morning, this is Dr. Sailaja, working as Associate Professor of Mathematics, MLR Institute of Technology, Hyderabad. Today, we are going to discuss about the inverse of the square matrix by Gauss Jordon method. First, we discuss the method, how to find the inverse of the given matrix. First of all, the given matrix should be a square matrix, then only we can find the inverse of the matrix. In earlier classes, the well-known method is to find the inverse of the matrix is A inverse equal to adjoint A by determinant A. So this is the general formula in earlier classes we learned to find the inverse of the square matrix. Now in engineering, here we are applying some echelon form to reduce the given matrix to echelon form, upper triangular matrix and lower triangular matrix. Then we find the inverse of the square matrix. So particularly in Gauss Jordon method, so in this method we suppose A is a non-singular square matrix of order n. Then we write the matrix A equal to IA. Here I is identity matrix and A is given square matrix. If the matrix A is of order n, then we take the identity matrix also order n. Now apply row transformations on the matrix A and also on the right side matrix, that is identity matrix. Same row transformations we apply on LHS of the given matrix A and on RHS on identity matrix. And we keep this matrix A on RHS, we keep it as same matrix. So here strictly we apply row operations of A and reduce it to I. That means here we apply row transformations on LHS of the matrix A until the matrix A reduced to identity matrix. Then this matrix becomes I equal to BA. So here B is inverse of the given matrix A. Whatever the transformations we are applying on matrix A on LHS, the same transformations we apply on RHS of identity matrix. These operations we continue until LHS of matrix A reduced to identity matrix. And here we get some matrix B which is not equal to 0, and here we call this matrix B as inverse of the matrix A. So this is about Gauss Jordon method. So here we strictly apply row transformations to reduce it to identity matrix, and we apply row transformations to reduce upper triangular matrix and also lower triangular matrix. Let us see the example. Find the inverse of the matrix A. Here we are taking fourth order matrix by using a Gauss Jordon method. So we write first the given matrix in the form of A equal to IA. A is a given matrix and I is identity matrix of order 4 and A is a again given matrix, that we write it as A only. Now apply row transformations. First step is reduce into echelon form, that is upper triangular matrix. So for that, here we are applying the row transformation. R1 is transformed to minus R1. That means we are multiplying with the first row with minus 1. So that we get minus 1, that is minus 1, 3 and minus 3, 1. So this matrix becomes like this, and the same transformation we apply on RHS of identity matrix also, that is minus 1, 0, 0, 0, and the remaining rows are same. Now apply the transformation. R2 implies R2 minus R1 and R3 implies R3 minus 2R1, R4 implies R4 plus R1. So that we get the elements below the diagonal elements should be 0. By applying these transformations, we get these elements becomes 0. The same transformations we apply on RHS of this matrix also. So that we get the matrix is minus 1, 0, 0. First row is the same. And the second row is 1, 1, 0, 0. Third row 2, 0, 1, 0. Minus 1, 0, 0, 1. Next, we apply the transformation R2 implies minus 1 by 2 R2. That means we are multiplying the second row with minus 1 by 2. Here minus 1 by 2 is a scalar. Since the matrix becomes identity matrix, further to make the diagonal element as 1. So that's why we are multiplying this second row with minus 1 by 2 so that we get the element minus 1 by 2 as 1. So apply this transformation. Then the matrix on LHS becomes like this. This element becomes 1. And the same transformation apply on RHS of this matrix also. So that minus 1 by 2, minus 1 by 2, 0, 0. And remaining first, third, fourth rows are same. And next one, here the elements below the second diagonal element must be 0. So for that we are applying again the row transformations. R1 implies R1 minus 3R2. And R3 implies R3 plus 11R2. R4 implies R4 minus 4R2. So that the matrix becomes 1, 0, 0, minus 5 by 2. And the third row is R3 plus 11R2. So this element becomes 0. Fourth row is R4 minus 4R2. For that, this element also becomes 0. So the same transformations we apply on RHS of this matrix also. Then the matrix becomes like this. Next transformation is we are interchanging the rows and the column. Interchanging the third row and the fourth row. So applying R3 interchanged as R4 and R4 is interchanged as R3. So that we get the matrix R3 becomes R4 and R4 becomes R3. So the same transformation on RHS of this matrix also. Then we get this is LHS and RHS. Now apply the row transformation. R2 implies R2 plus R3 and R4 implies R4 plus 3R3. If we apply these two transformations, then we get the matrix 1, 0, 0, minus 5 by 2 and 0, 1, 0, 1 by 2 and 0, 0, 1, 0, 0, 0, 0, 1 by 2. Almost we are getting the identity matrix on LHS. So we apply these transformations until we get the LHS of the given matrix becomes identity matrix. So for that we are applying strictly row transformations to reduce the given matrix to upper triangular matrix and also lower triangular matrix. And the same transformations we apply on RHS of this matrix. So then the matrix becomes like this. And so finally, if we apply R4 implies 2R4, that means multiply the fourth row with 2, then we get the last element becomes 1. So 1, 0, 0, 0, 1, 0, 0, 0, 0, 1, 0, 0, 0, 0, 1. Now this matrix is identity matrix. So the given matrix becomes identity matrix. Now the right hand side matrix is the inverse of the given matrix. That means if we multiply these two matrices, this matrix and the given matrix A, then we get the identity matrix. So that's why this matrix is called A inverse or B. Let it be B. Now this is in the form of I equal to BA, where B is A inverse. So this is a procedure to find the inverse of the given square matrix by Gauss Jordon method. So in this method, strictly we apply row transformations on LHS and RHS, whereas LHS is the given matrix and RHS is a identity matrix, and apply row transformations until the LHS of the given matrix becomes identity matrix, and whatever the matrix we get on RHS, that matrix is said to be inverse of the matrix A. So this is the second example. Here also the given matrix is of order 4. So that's why we take the identity matrix also order 4. So write the matrix in the form of A equal to INA, A equal to INA. Here N is the order of the given matrix, I is also the same order. Apply row transformations on both sides of the matrices, that is matrix A and the identity matrix. So finally we get the identity matrix. So right side, the matrix is inverse of the given matrix. So this is some exercise problems. Here answer also I have given. You can check your answer with this. Thank you.